Hello and welcome to Context Free, where we talk about programming languages. Today I'm going to talk about code as data, and yes, I will discuss Lisp and homoiconicity, but I want to start with C#. In my history of C#, I talked about language integrated query, or LINQ, as an innovative feature of the language, and I'm going to hold to that. However, a lot depends on how you look at it. As the preacher said thousands of years ago, there's nothing new under the sun. Well, LINQ can be used to query databases or also arrays in memory. So I have an array of persons here with names and ages, and I can query for their names. I can say var names equals from person in persons select person.name, and I can print those out to the screen for each name in names console.writeLine name. And I should see here Anne, Bob, Cal, and Deb, because they're the names of the persons here in my array. If I run it, that's what I get. I can also put conditions on my query. So for example, I can put a condition on the age, where person.age is greater than or equal to 18. And we see here for Bob, that doesn't apply, so we'll only get Anne, Cal, and Deb. Let's go ahead and run this and see how this works out. That's exactly what we get, Anne, Cal, and Deb. Now we can do something very similar in Python, where this runs in memory and does queries that look similar to this. So I can say names equals, with comprehension syntax here, I want to get each person's name for person in persons if person age is greater than or equal to 18. And then I can print these out for name in names, print name. Actually, it's the same thing that I saw in C#. Anne, Cal, and Deb. If I run this, that's what I get. Great. So far, so good. Very similar things are happening here between Python and C#. However, there's other things that can be done in C# that aren't quite the same way in Python. Let's go look at a database query here. And using this product here called LinkPad, which makes it easy to interact with LINQ. I'm going to be querying from this products table from a database, from product and products, where unit price is greater than 10, order by unit price, select the name and the unit price. If I run this, I get my results here. Worth pointing out also that LINQ can be using query syntax or also method syntax, where you do a sequence of calls here that sometimes you can see this in other languages as well, where you give anonymous functions to do your queries. So get the products where unit price is greater than 10, order by the unit price, and select the name and unit price. Now, this is nice and good. These are relatively equivalent things here in LINQ. However, what I need is this query as data if I'm going to convert it to SQL and have it run efficiently on my database server instead of locally in my own process. So for example, it would be great to have this where clause, for example, as data so I can turn it into equivalent SQL. For instance, right here, the SQL gets generated from this LINQ expression, select name and unit price from products where unit price is greater than some parameter, order by unit price. So this can be sent off to the database and executed efficiently there. Well, let's see how this works in C# in order to get data from our code in order to do, say, converting to SQL. So let's do a simpler example, though. Let's make a little example here where we're going to have some kind of condition. Let's make a function from integer to Boolean. I'm on fire today for typing. Let's see if x is greater than some other value. And let's set that value to 2 for convenience sake. So we have a function here, an anonymous function that will test to see if the parameter is greater than the value y. And let's use this function. Let's see if 3 is greater than y or 2. If we run this, we see, yes, it is greater. That's what we expected. If we put a 1 here, we'd see false. Okay, so far so good. This is code I can execute, but it's not convenient for data, say, for converting to SQL. In order to get that in C#, the compiler helps us a lot. If we just say, instead of a function, we want an expression representation of that function, that's what we're going to get. And the compiler knows how to handle this and build this tree at compile time, such that it's going to be more efficient handling when we go to run it. Okay, so let's go ahead and print this to the screen, see what we get. Okay, here's our data. We see we have a function here which goes from x to x is greater than some local variable y. This right here is not executable. I can't say execute it with a 3 because it's not a function. It's data that represents the function. So instead of, for example, trying to call it, let's get data out of it. We get the function node type, because this is a syntax tree. We can get the body of it. We can get the body's node type. Let's run this here. So for example, we see our original full syntax tree. What type is that? It's a lambda, or an anonymous function. What's the body of it? X greater than local variable y. What's the type of this greater than? It's a greater than node type. So this is how we can get data out in a convenient fashion in order to, say, creating SQL queries. How do we do this in Python? Well, it's not quite as straightforward, but there are various options available. Here's a similar example. Y is 2. We have a function which is checks to see if x, its parameter, is greater than y, then 3 is greater than 2, so we should see true over here. That's what we see. Great. Now, what happens if we want this as data? Well, the most obvious thing to do in Python is to put it in a string. And conveniently, there's a standard module called AST with a function called parse that we can parse this to an expression that knows Python syntax. Parse source. And let's actually fancy print this expression. If we run this, we get our syntax tree out of here. We have a body of this. What's in there? It's a lambda. It has argument x. And the body of the lambda is compare x greater than y. Sweet. Well, maybe I want to reference my local variable y instead of having me a string y here. Well, one way to do that in Python would be to use format strings and use string interpolation. Instead of seeing y here, I should see the 2 now instead. So now we see x greater than 2, so I can reference local variables. However, this still has the problem of, number 1, I'm parsing at runtime. Every time I run through this code, say if we're in a function somewhere. Number 2, I don't get this looks nice in my editor here. This doesn't know what this is. It's just strings. That's not ideal here. Well, there are other ways to get at your data in Python. Let's do instead source equals, oh look, inspect get source. I wonder what get source does. Get source of my function here. Let's just use this for now. And let's print out this source to see what happens. We're going to find it's not ideal. I would like to see the source that's just lambda x, x greater than y, but instead I get the entire statement. So that's not ideal. When people use this method in Python, they'll usually create full functions for this. So I'll say example, fun again, x, return x greater than y. Now if I try to get source of fun again, instead of getting source of an expression that didn't quite work the way I wanted it to, we're going to see that we get the source of the function. So this is a little more predictable and often the way you'll use this strategy in Python. If I want to parse it out and print it, I'm going to see a syntax tree that I can rely on to some extent. Now, beyond syntax trees, Python actually has a compiler. So that's what it starts. It compiles to its own bytecode and then executes the bytecode. We can get bytecode of lambda expressions. So let's try that out. There's the disassembly module in Python. I can say disassemble some function here, but I even just say fun in Python. And if I run this, I'm going to see the bytecode, load x, load global y, compare greater than, return value. Well, that just printed a console, not as useful. How about we get instructions instead? And we can make those instructions into a list, and we can print those to the screen or do whatever else we wanted to with them. It's not going to be as convenient as an AST, but it's something that does give me data from arbitrary lambda expressions, for example, if that's what we wanted to do. I want to show one final example of something you can do in Python, which works in a number of languages, any language that has operator overloading. A very simple class here, just so I can demonstrate this. And when you can do operator overloading, you can make it do whatever you want it to. In my case, I'm just going to prove that I can create data out of it. I'm going to say, make a list of my initial value, greater than string, and my other value. I'm only overloading greater than for the sake of the simple test here. Now I can say print term x greater than y. And when this greater than gets called, it's going to call my greater than, which is going to build this data. And I can do anything I want to do with this data. So I see here x greater than 2 because it referenced the local variable y. Sweet. Now, how does SQL query generation usually happen in Python? The most popular language library, as far as I know, is the Django query library, which doesn't look anything like this. A query from the entry table where number of comments is greater than the number of pingbacks. This is not taking advantage of the syntax like I'd like to see. As far as I know, the second most popular library for these things in Python is SQL Alchemy. And it's going to be a lot closer to what we're expecting to see relative to our current topic of today for code as data. Query.filter, user.name equals ed. And as far as I know, you can do things like greater than, less than, and so on in SQL Alchemy. So this is taking better advantage of the language syntax and code as data for making a good user experience for the programmer. Other things other than creating SQL, what might we want to do? Here's an example from the Programming Languages subreddit from a couple days ago where someone brought up using Python syntax to create grammars for other languages, where again, you're going to use Python syntax and that code as data to generate a separate grammar. Alternatively, things like TensorFlow will use code as data, where the greater than here is actually an overloaded greater than operator. And I can either run in eager mode, where I actually get the result out, or I can run it in graph mode, where I just get a description that I have a greater than operator going on here. TensorFlow wants the data so it can say run the code on the GPU instead of in the CPU, or do other kinds of machine learning things with it. Now, I said we'd get back to Lisp. Lisp is the most well-known example for code as data probably in modern times. And it's also one of the earliest programming languages that's still in use today. It's from 1958 originally. Lisp is referred to as a homo-iconic language, meaning same representation, where code and data look the same. The term homo-iconic seems to have come probably from other languages as well, but the most common example today is Lisp. I'm going to show an example using a programming language called Scheme, which is a dialect of Lisp. If you haven't seen Lisp or Scheme before, it looks different than some other languages. We wrap our function calls in parentheses. And in Lisp or Scheme, our code is nested linked lists, and our data most often operate on is nested linked lists. Here's a hello world. We're going to print hi. Instead of printing hi, I could do some math, where I would say I want to add 1, 2, 3, and 4. I should see print 10 now. Okay, 10 comes out because that's the sum of 1, 2, 3, and 4. Sweet. Let's go to our previous example of we have a y, we have an anonymous lambda function that says is x greater than y, and let's call 3 on it. That should give us true. Oh, there it is. If I were to call 1, 1 is no longer greater than 2, and we see false. Sweet. Now what happens if I want data instead of a function I can execute? I want a linked list, not an executable function. Well, I just put a tick in front of it, and now all of a sudden, I have data. The syntax tree is nested linked lists, just like the code was originally. For run this, these right here effectively is a list of symbols of lambda x greater than x and y. I can try to call it as a function. Is 1 greater than 2? I don't know. Let's find out. Does it work? It says this is not a function. Notice here we see more explicitly that each of these things are quoted here. Notice also we see the y here more as a string. If we wanted it as the value 2, we could interpolate it. Here the term is unquoted, such that I get the value 2 here instead of the original. Again, I can't execute it as a function, but I see the value 2 here instead. Anyway, this is an example again of a homo-iconic language where the data and the code look the same. And code as data is very natural. It doesn't require such a simple language to do this kind of thing, though. Julia is a language, for example, that competes with Python and MATLAB in the scientific computing domain. We have our example here again, y equals 2. We have a function which goes from x to x greater than 3. Fun of 3 is 3 greater than 2. It should be true. And yes, indeed, it is true. Now, if we want to turn this into an expression, a syntax tree, the Julia language helps us here, just like Lisp and C# helped us out. And this is a lot like how I might do it in Lisp, actually. We just wrap it around with a quoting operator that now, instead of being a function, it is a tree of data. And we see here that will print out this expression here. We can't call it as a function. We see it's a function that goes from x to x greater than y. Notice y here again is a string. I can do the unquoting sort of thing or interpolation from before also by using a $sign in front of the y. And we see here instead now x greater than 2. So here's an example of having this full-featured code as data in a convenient fashion in a language with richer syntax than Lisp. And what you like better could be up to you. Anyway, I hope it's been fun. Bye, y'all.